Let f of x be 3x squared and g of x be the square root of x minus 2. Find f of g of 3. So that means, first of all, we're going to take g of 3. Now g of 3 is take g of x, which is the square root of x minus 2, but instead of x, we're going to use 3. So it's the square root of 3 minus 2. And all of that's going to be input into f. The square root of 3 minus 2 is the square root of 1, which is 1. Now we've got the output from the g part, we're going to input that into f. F is 3x squared, so it's going to be 3 times 1 squared, which is equal to 3. So f of g of 3 is equal to 3. What about f of g of x? This is saying what's the function for the composite function, f of g of x. The first thing I would do in this case is rewrite this as f of g of x, like that, and then I would do exactly the same process. G of x was the square root of x minus 2, so I substitute that in for g of x, and then f was 3x squared, so this is going to be 3 times this thing, root x minus 2 squared. That is 3 and then x minus 2, or 3x minus 6. Find the domain and range of f of g of x. Now, just looking at this, it looks like it might be all real numbers for both of them, but remember we have to consider the multiple things that are happening. So first of all, what happens with g? Well, when we put things into g, g is the square root of x minus 2. So we can put anything in as long as x is bigger than or equal to 2. And we can get anything out of that which is bigger than or equal to 0. Now thinking about f was 3x squared. What can we input into 3x squared? Well, we can input anything bigger than or equal to 0. That's absolutely fine. We don't need to restrict this any further. What would we get if it's bigger than or equal to 0? We can get anything bigger than or equal to 0 out. So our domain is going to be all values of x such that x is bigger than or equal to 2. And our range is going to be all values of y such that y is bigger than or equal to 0.